is broken up into three main parts. Firstly, we're going to build a simple maze game using a collection of C++ files that you can download from the classroom area. We'll do this on the command line, which is how you'd be working if you didn't have access to an IDE. Secondly, we're going to import that game into an Eclipse project. Thirdly, we're going to configure that Eclipse project so that we can build and run the game from inside Eclipse. Before we get started on that, we're going to install the header files for a library called ncurses, which we'll need on our machine to build and run the game. So, in a terminal window, type sudo yum install ncurses-devel. The devel suffix tells yum to install the development version so that we can include header files in our code and use the library for development. That installs nice and quickly, so now we can open up our archive file and build a program. To follow along with this lesson, you'll need to download the archive file called mazerun.tgz, which you can find under lesson 3 in the classroom area. Once you've done that, let's go into the File Explorer in Fedora and view the Downloads directory, which should be where your TGZ file is saved. We want to untar this file so we can access the contents. Now, you can do this in the graphical interface, but I like to work on the command line. And we're going to build on the command line, so let's open a terminal. I've installed a package on this machine actually that puts a shortcut on the context menu, which you can see here. It says open in terminal. That means it will open the terminal window at this location, which is really handy. I've got a short post on the blog if you want to set your machine up the same way, and there's a link to it in the checklist for this lesson. In the meantime, I'll assume you haven't got that, so let's close all this and open a terminal window in the usual way. In terminal, cd to the downloads directory, and if I long list everything with LL, we can see the mazerun.tgz archive file. We want to extract the contents here, so type tar -xvf mazerun.tgz. The options passed to tar are X for extract, V for verbose, so it will list all the files as it extracts them, and F is for archive file, i.e. the name of the archive file you're passing to it, which is mazerun.tgz. Once the files are out, cd into the source directory and let's have a look at the contents. Okay, we've got all our source code here, plus a build file. To build, all you need to do is type /build and press return. When it's finished, long list the directory contents and you should see the mazerun executable. If we run that now, we get our game. Brilliant. So we've got a working program, a little build file of our own, and all our source files in one place. The thing is, we want this in Eclipse so we can make use of all the features that will make coding faster and easier. So let's get this code into the IDE so that we can start using them. Right, I've opened up Eclipse here and you can see our Hello World project there on the left. To get our mazerun program into Eclipse, we're going to create a new project and then import our files. First of all, go to File, New C++ Project. Give the project a name. I'm going to call it mazerun. Then make sure Empty Project is selected under Project Type and Linux GCC is selected under Toolchains. Click Next and you can see our project will have a debug and release configuration. That's exactly what we want, so we can leave all this as it is and click Finish. Okay, so here's our new mazerun project on the left in the Project Explorer window. Next we want to right-click the project and select Import. In the window that pops up, we want to choose General File System and click Next. Eclipse asks us for the directory we want to import from, and that is going to be our source folder that we extracted from the archive file in our downloads directory. So navigate to downloads source and click OK. Now we need to check the files that we want to bring in. Remember that we've got a little build file in our source directory, and we won't need that because Eclipse will manage the build for us. So check source in the left column, and then in the right column uncheck the build file and leave the remaining source files checked. Finally, make sure that this create top level folder is checked. This is important. Don't forget to do this. It keeps our source files nice and neat in a folder within the Eclipse project. Then click Finish. Now if we have a look under our Maze Run project and expand the source directory, we can see all our C++ files. These files have been copied into the Eclipse workspace. They are not the files that you've got in the download directory. So when you create a project and import the files this way, you won't be disturbing your original files. At this point, I'm just going to close the Hello World project we created earlier by right-clicking and selecting Close Project. You can see that the folder icon changes to a closed folder and the source file disappears from the editor. Now when I build or search, it won't include this project in the results. It's completely separate from what we're working on. You can reopen other projects anytime, or this project, by right-clicking and selecting Open Project. Okay, so now we're going to build the Maze Run project by clicking the hammer icon, which means build all. You can see the build output running past in the console window here. When the build finishes, if I just drag this window up a little so you can see it better, it says failed at the bottom, and just above there we've got a fatal error, ncurses no such file or directory. Now that's intentional, don't panic. We installed the ncurses devel headers earlier, so what's going on? This is Eclipse telling us that the build process in Eclipse doesn't know about the ncurses.h header file. It doesn't know about the header file because although we have included it in our source code, we aren't linking the library as part of the build process. On the command line, you'd pass a library to the linker with the -l option, so we have to find the equivalent way to do this in Eclipse. Right-click the project and select Properties, then select C, C++, General and Paths and Symbols. Choose the Libraries tab. This is the location to use when you want to link in any non-system libraries. Make sure that you select all configurations from the drop-down box at the top. If you forget to do this, there will be an extra checkbox in the dialog where you add the library name. You don't want to just add it to the debug configuration or just the release configuration, because then at some point when you want to build the other version, debug or release or debug, you'll have to go back in and go through this process all over again. So we want to make sure we do it for all configurations now. Click Add and then just add the library name. You don't have to add -l in front or anything like that like you do on the command line. Eclipse takes care of that for us. Libraries like ncurses and boost will install in a standard location on your machine, so you don't need to add an extra library path. If you're using libraries that live somewhere else on your computer, outside the normal search paths, you can put this location in the library paths tab, which you can see here next to the libraries tab. Okay, let's build the project again. This time we can see a new error. A null pointer was not declared in this scope. Now this error is occurring because I've used the C++11 keyword null pointer in the code, but our compiler hasn't implemented C++11 as the default standard yet. So we need to tell the compiler that this code should be compiled with the C++11 compiler flag. So to do that, we go back into Project Properties. This time we want to select C, C++ build settings. We can see the tool settings here, which encompasses anything we want to tell the compiler about. This is where you select warning levels, optimizations, and any other flags and options that you would normally pass to the compiler on the command line. Now, in Eclipse versions prior to Luna, you had to add the standard, the C++ standard, under the miscellaneous heading. Luna, however, is set up with C++11 under what's known as a dialect option. So I'll show you both ways, just in case you're ever using an old version of Eclipse or an older version of Eclipse. First of all, make sure we're adding the relevant options for both debug and release configurations. Okay, and then to add it as a miscellaneous option, remember this is for Eclipse versions prior to Luna, just add click on miscellaneous and then enter -std equals C++11. There's a caveat to this. If you're running a version of GCC prior to version 4.7, that needs to be -std equals C++0x. If you aren't sure about your GCC version or your Eclipse version, the easiest thing to do is just put -std equals C++0x under miscellaneous. If you're on the latest and greatest, as we are here, then go to the dialect option and select ISO C++11. Okay, so we come out and build again. And this time it builds without errors, hooray! So what we've done here, to recap, is we've created an empty project, imported our source code, added a library and included a build option. This pattern can be used for all of your own programs and is the most straightforward way to move source code into Eclipse projects. Now we're going to have a look at running the code. Okay, so if you try running this program in Eclipse with the little green run arrow here, it fails with this error opening terminal unknown message. This is because Eclipse will try to run a console program in its own built-in console window, which you can see here. This isn't the same as the genome terminal that we use ordinarily. And because we're using the ncurses library in our game, Eclipse gets all confused about what to do and it can't display our program at all. What we need to do when we have a program that won't run directly from Eclipse is set up what's called an external run configuration. This is just a collection of settings that tell Eclipse how to run the program we have created. To create the run configuration, we're going to use this external tools button. Actually, let's access it from the menu. So go to Run, External Tools Configuration. We get this box pop up where we can manage what's known as the launch settings, i.e. what Eclipse will do when we press run. So first we want to select what we want to run, and in our case it's a program. Then select the new launch configuration button. You can see it's created a new configuration for us there on the left. So first we want to give it a name that we can identify. I'll call it Run Maze Run, which is exactly what I want it to do. Okay, in this location box we want to put the path to the normal terminal that we use, the genome terminal. And on Fedora that path is /user/bin/genome terminal. Next, in the working directory box, you want to browse to the location of the binary that we've built in the Eclipse project, and that's under the project folder and the debug folder. You could create another one of these launch configurations for the release version, in which case you'd choose the release folder here. We haven't got one of those because I haven't built a release version of the game. Finally, under arguments here, you want to type -e./maze_run. That's the argument that we're passing to the program specified in the location box. So it sounds complicated, but in a nutshell, what we're telling Eclipse to do when we press run is run the genome terminal from the working directory debug and pass the terminal -e maze_run, which tells terminal to execute a binary file called maze_run. This way, instead of using Eclipse's console to run our program, we are just specifying the system console to run it instead. It's just adding in a couple of extra steps to make sure we get the output that we want. Okay, so click Apply and Run, and look at that, there it is! A terminal window opens up automatically and our game starts. Isn't that amazing? That's the wonderful thing about really knowing how to use a tool. You can make it do so much of the work for you, freeing you up to concentrate on being more productive. And I love that. Just 2 more things to cover before we finish up with this lesson. First of all, I wanted to point out that once you've run a launch configuration, like the one we just created to run our game, Eclipse will remember it for you, and you can see it here on the Run External Tools button, or listed here on the Run External Tools drop-down menu. So it's nice and easy to run the game without having to navigate through too many menus. However, there is no keyboard shortcut for running the external tool config, and I'm a huge fan of keyboard shortcuts. Moving the mouse around the IDE constantly is tiring when you spend all day doing it. So learning a few important keyboard shortcuts in Eclipse will really save you time and decrease your chances of repetitive strain injury. So the second and final thing before we wrap up is to show you how to set up your own keyboard shortcuts in Eclipse for things that you do frequently. And it really does make a difference to how fast you can work. To set up a shortcut to run our game, we need to have a look in Windows, Preferences, General Keys. Here we've got a really great big list of all the actions that Eclipse supports and the keyboard shortcuts where specified. To find the action we want, type run last LAU in the filter text box. That brings up run last launched external tool, and that's the one that we want. Right, it's a bit awkward to view here on my screen as it's off the bottom of the page. But if we scroll down, we can see the binding box underneath. Click on this box and then press the keyboard shortcut that you want to use. To run our maze, I'm going to use F9, which is nice and simple, but you can use anything, such as Control and a letter or Alt plus Shift and a letter. Any combination that works for you can be used. Now, a warning. If you do allocate a shortcut that is already in use, Eclipse doesn't tell you. You can make Eclipse do some really confusing things by reusing existing shortcuts. It seems to prioritize the ones that you set as the user over the system shortcuts. So if you duplicate a shortcut for a different action, Eclipse will use your action, not the default one. So the best thing to do when you want to add a shortcut is decide beforehand what you want the key combination to be. Then order the list of keys by binding and scroll down to check if the one you want to use is already in use. Make sure you check the when column, as keyboard shortcuts are view specific, i.e. something that works in the editor might not do anything when you're debugging. Sometimes the binding you want to use might exist, but it's for something you don't care for or use, in which case feel free to repurpose it for something else. You can always set everything back to how it was using this Restore Defaults button at the bottom of the window. Last of all, you can bring up a slightly more convenient list of shortcuts by pressing Ctrl-Shift-L. Here we get this nice little box that has a very long list in it. This list covers the shortcuts that are available in your current state. So this box will look different when you are debugging, say, compared to editing code. You can move from here to the keys page by pressing Ctrl-Shift-L again. It says that at the bottom. Okay. In reality, you will probably only edit or add a keyboard shortcut once or twice, so I don't want to spend any longer on this. Let's close everything down, and then I'm going to use the keyboard to build. That's Control B, and there's nothing to be done because I haven't made any changes to the code. And then I'm going to press our new keyboard shortcut F9, which I know you can't see me doing, but trust me, that is what I'm doing. And all being well, there's our game. Okay, we've covered quite a lot in this lesson, but it's provided you with a really solid grounding on how to get external code into Eclipse, configure project settings, and make Eclipse do what you need it to. We've come a really long way, but there's much more to look at. In the next lesson, we're going to take a tour of Eclipse and get you familiar with some of the most common keyboard shortcuts before jumping in and having a go at editing the code yourself.